Module 1, Section 1.2, Graphs and Lines. Objectives. Objective 1. Draw graphs for equations of the form ax plus by equal to c. Objective 2. Graph and write equations of horizontal and vertical lines. Objective 3. Define and compute the slope of a line. Objective 4. Find an equation of a line using the slope-intercept form and the point-slope form. Objective 5. Find x-intercept, y-intercept and slope using the graph of a line. And Objective 6. Application problems. Here is a quick review of the rectangular coordinate system. The Cartesian coordinate system. To plot a point in this plane, say for example we have -2, 3, we identify the x coordinate and y coordinate. X equal to -2 and y equal to 3. X equals -2, which is up here, and y is 3. So we will be plotting that point as a second quadrant point, -2, 3. Linear equations in two variables. A linear equation in two variables is an equation that can be written in the standard form ax plus by equal to c, where a, b, c are constants, a and b are not both 0 at the same time, x and y are the variables. A solution of an equation in two variables is an ordered pair of real numbers that satisfy the equation. For example, 4, 3 is a solution of the equation 3x minus 2y equal to 6. The solution set of an equation in two variables is the set of all solutions of the equation. The graph of an equation is the graph of its solution set. To find a solution to a linear equation in two variables, do the following. Substitute a value for one of the variables, x or y. Then solve the equation to find the other variable. Here is an example, 3x minus 2y equal to 6, and we need to find a solution for this equation. So I'm going to take x equals 4, and then I can substitute here, getting 3 times 4 minus 2y equals 6. Solving for y, we will get -2y equals 6 minus 12, which is -6. So y value equals -6 over -2, which will come out to be 3. The solution point will be 4, 3. Objective 1. Graph a linear equation in two variables. The graph of a linear equation of the form ax plus by equal to c is a straight line. To graph a linear equation in two variables, find at least two ordered pairs that are solutions to the linear equation. Plot the ordered pairs. Then draw a straight line through these points. Here is an example. 2x minus 6y equal to 12. We need to graph this equation. So I can take x equal to 0. Y value is calculated as 2 times 0 minus 6y equal to 12. So y value will be equal to 12 divided by -6, which is equal to -2. That is this point calculated here. So we will get another point corresponding to x equal to 6, y calculated as 0. So this is another point, and I can plot that up here. So this will be 6, 0. This will be 0, -2, and draw it using a straight edge. Another example, graph 3x minus 4y equal to 12. So if I take x equals 0, I can calculate y value as -3. So which is like 3 times 0 minus 4 times y equal to 12. Solving for y, -4y equals 12. Y equals 12 divided by -4. That will be -3. That's how you get this point. So we need one more solution. So I can take x equal to 4. So I take x equal to 4, and that will calculate y to be 0. Again the steps will be 3 times 4 minus 4y equals 12. So we get 12 minus 4y equals 12. So negative 4y will be 0. Y will be 0 divided by negative 4. That comes out to be 0. Okay, here this is the second solution. So now we need to plot these points. X equal to 0, y equal to negative 3. So which will be plotted up here. X equal to 4, y equal to 0. So we have 2 here, 4 here, and y is 0. So therefore the point will be on the x-axis. Join these 2 points using a straight edge, getting the line. Here is another example. We have y equal to negative 2 by 3x minus 3. We need to calculate 2 points. Again we are substituting x equal to 3. Then y value is calculated as negative 5. So 3 negative 5 is a solution point. Substitute another value, say x equal to 0, and calculate y as negative 3. 0, negative 3 is the second point. So we are going to plot these points now. X equal to 3, y equal to negative 5, which will be up here. So this is x equal to 3, y equal to negative 5. So that is the first point. Then we have the second point, 0, negative 3. So x equal to 0, y equal to negative 3 will be placing the point up here. So once we do that, we need to join this by a straight edge. So the line will be going like this. One thing to remember here is, if we take x value to be multiples of 3, we can get 2 by 3 times x simplified as a integer. So we will get points that can be plotted easily in the on the graph. Using a graphing calculator, graph the equation 2x minus 6y equal to 12 using a graphing calculator. First we need to get y in itself. So we solve for y from the equation, subtract a 2x from both sides. So we get negative 2x plus 12 as the value for negative 6y. If we divide with the negative 6, we get y value to be 1 by 3x minus 2. So this is the solution for y. Now we are going to use the calculator to graph this function. Press y equal to, and we type in the formula 1 by 3x minus 2, which is the solution for y. Now we can press the graph key, we get the straight line here. Sometimes you may want to adjust the window in order to get the graph. Objective 2. Horizontal and vertical lines. If an equation is written in the form y equal to b, where b is some real number, then the graph of the equation is a horizontal line. It is a straight line that is parallel to the x-axis. Here are some examples. Y equal to 4, y plus 9 equal to 0, 2y minus 3 equal to 10. Notice there is no x term in these equations. So this graph is showing the graph of y equal to 4, which is a horizontal line. If an equation is written in the form x equal to a, where a is some real number, then the graph is a vertical line. It is a straight line that is parallel to the y-axis. Examples will be x equal to 4, x plus 9 equal to 0, 3x minus 3 equal to 10. Here we notice that there is no y term in these equations. The graph of x equal to 4 is showing up here. Write and graph the equations of the vertical and horizontal lines through the point negative 7, 4. This ordered pair tells you that x value will be negative 7, y value is 4. So if you write the equations y equal to 4, you will get a horizontal line, and if you write x equal to negative 7, we will get a vertical line. Objective 3. Slope of a line. If a line passes through two distinct points P1, x1 y1 and p2 x2 y2, then its slope is given by the formula m equals y2 minus y1 over x2 minus x1, which is also written as rise over run. Y difference is the rise, x difference is the run. Slope provides a measure of the steepness of a line relative to the x-axis. Geometric interpretation of the slope. Slope is positive if the line rises from left to right. Slope is negative if the line falls from left to right. Slope is 0 if the line is horizontal. Slope is undefined if the line is vertical. Example. Find the slope of the line through the points -2, 4 and 3, 6. So our first point will be having x coordinate x1, y coordinate y1. Second point will have x coordinate x2 and y coordinate y2. So using our slope formula, slope m equals y2 minus y1 over x2 minus x1. I can substitute the values. 6 minus 4 divided with 3 minus -2. So when I simplify this, I will get 2 in the numerator. 2 negatives will be coming as positive, so it will be 3 plus 2 equal to 5. So 2 divided by 5 is the slope of the line through these two given points. Objective 4. Slope-Intercept Form. The equation y equal to mx plus b, m equal to slope and b equal to y-intercept is called the slope-intercept form of a line. Slope is the coefficient of x. Y-intercept is the constant number. So m is the slope, b is the y-intercept. Here is an example. If y equal to 3x plus 5, the slope is 3 and the y-intercept is 5. If the equation is not in the slope-intercept form, solve to get y by itself to get the equation in the slope-intercept form. Find the slope and y-intercept from the equation of a line. Let's work out this example. Find the slope and y-intercept of the line whose equation is 5x minus 2y equal to 10. So we are going to solve the equation for y in terms of x. Subtract a 5x from both sides, getting this equation. Divide by -2 to get y in itself. So our equation will be y equals 5 by 2x minus 5. So now we can identify the slope. Slope will be the coefficient of x, and the y-intercept is going to be the constant term, which will be -5. Find the equation of a line with slope 5 and y-intercept -3. Here we can use the slope-intercept form, y equal to mx plus b. So identifying the slope as 5 given and b as -3, I can write the equation as y equals 5x minus 3. So this is going to be the answer here. Point slope form. The point slope form of the equation of a line is y minus y1 equals m multiplied with x minus x1. Here m is the slope and x1 comma y1 is a given point. Let's do an example. Find the equation of a line that has slope 2 and that passes through the point -4, 3. We are going to use the point slope form of a line. Y minus y1 equals m multiplied with x minus x1. So m value is given as 2, x1 value is given as -4, y1 value is given as 3. So when I substitute, I will get y minus 3 equals slope 2 multiplied with x minus x1 itself is negative, so we need to have one more negative, -4. So we have a negative here, another negative. So I can actually distribute this. 2x plus 8 equals y minus 3 And I can rewrite this again as y equals 2x plus 11. Find the slope-intercept form of the equation of the line through the points negative 5, 7 and 4, 16. Here we are given 2 points. So therefore we need to find the slope first. So slope is going to be y2 minus y1 over x2 minus x1, and it is calculated as 1. So slope is 1. Now we can use the point slope form of the line with the slope equal to 1 and one of the points as x1, y1. So we could also be using the other point if we want to. So substituting in the point slope form, we get y minus 16 equals 1 times x minus 4, and solving for y, we will get y equals x plus 12. Objective 5. X-intercept, y-intercept and slope of a graph. The x-intercept of a line is the point where the line crosses the x-axis. That's up here. X-intercept is an ordered pair with the coordinates a, 0, where a is a real number. To find the x-intercept of a linear equation, we substitute y equal to 0 and solve for x. For example, if 2x plus 3y equal to 6 is the line, we can substitute y equal to 0, getting the x value as 3. So 3, 0 is the x-intercept. The y-intercept of a line is the point where the line crosses the y-axis. The y-intercept is an ordered pair with coordinates 0, b, where b is a real number. To find the y-intercept of a linear equation, substitute x equal to 0 and solve for y. Here is an example. 2x plus 3y equal to 6. When x equal to 0, I can calculate y as 2. So 0, 2 is the y-intercept. To find the slope of a line, use x and y intercepts as the points and use the formula m equal to y2 minus y1 over x2 minus x1. Example. Find the x and y intercepts, slope and the equation of the line from the given graph. So we do have the 2 points. Looking at the x-intercept, we get 6, 0 as a point on the line. And looking at the y-intercept, I can get 0, negative 2 as the y-intercept. So these are points. Now we are going to calculate the slope. Slope will be y2 minus y1 over x2 minus x1. So we calculate that as negative 2 minus 0 divided with 0 minus 6. So that is calculated as 1 over 3. So once you get this slope, I can use this formula. Y equals mx plus b, where m is the slope, which we know is 1 by 3. So 1 by 3x plus b is going to be the y-intercept, and the y-intercept is negative 2. So the y-intercept will be written as negative 2. So my equation will be y equals 1 by 3x minus 2. Objective 6. Application problem. A farmer buys a tractor for $154,000 and assumes that it will have a trade-in value of $83,000 after 10 years. If its value is depreciated linearly, we need to find answers to these 3 questions. Find the linear equation that relates value V in dollars to time t in years. Calculate the depreciated value of the tractor after 6 years. When will the depreciated value fall below $50,000? Here is the solution. We know that when t equal to 0, that means initially the value is going to be $154,000. And when t equal to 10, that means after 10 years, the value is going to be $83,000. So we have the 2 ordered pairs, 0, 154,000, 10, 83,000. we find the slope of the line using the slope formula. The y-intercept is already known because when t equal to 0, the value of b is $154,000. So the y-intercept is going to be 154,000. Slope is calculated using the slope formula here. So slope is going to be negative 7,100. That is the value for m. Therefore, our equation can be written as Vt equals negative 7,100 times t plus 154,000. So this is parallel to y equals mx plus b. V stands for y and t stands for x. Slope is negative 7,100. Part 2. Calculate the depreciated value of the tractor after 6 years. We already have the equation for the model. Value equals negative 7,100 times t plus 154,000. Now the t value equal to 6. So I can calculate the value corresponding to t equal to 6, which is like V6 equals negative 7,100 multiplied with 6 plus 154,000. When we simplify this, we will get $111,400. So that is the value after 6 years. Part 3. When will the depreciated value fall below 50,000? So this time we know the value of V, which is V equals 50,000, and we are trying to find out the value of t, which means I need to come back and solve the equation. 50,000 equals negative 7,100 times t plus 154,000. So when I solve for t by isolating the variable, I can get 154,000 then minus 50,000 divided with 7,100, and that will calculate to be 14.6478. We can round this to 15. So after 15 years, the depreciated value will fall below 50,000.